Hello students, this is Mr. Akash Vasan Nesarkar, lecturer in chemistry, Department of Chemistry, KLS Gokte PU College of Commerce and Science, Belgavi. Students, let us glance what we have discussed in a last class. We studied the 4 points. The first one, we discussed the types of adsorption based on the nature of force of attraction present between the adsorbate and the absorbent. That is, the first type is physical adsorption, second type is a chemical adsorption, and also we studied their various examples. The second one, also we compared the physical adsorption with that of chemical adsorption in various manner. And the third one, we came to know how the adsorption of a gas on a solid depends on various factors. And the fourth one, we come to know the meaning of adsorption isotherm. On above all points, we are having the assignment second of this topic. There are 8 questions which are really important, and these all questions are based on previous class. And if you understood the previous class well, then you can answer all these questions. So let me read all these questions. The first one is, what is chemical adsorption? It's a really simple one. Second one, define physical adsorption. Third one, give any one difference between physical adsorption and chemical adsorption. Fourth one, mention any two factors which affect the adsorption of a gas on a solid. Fifth one, what is the effect of temperature on adsorption of a gas on a solid? Sixth one, how the adsorption of a gas on a solid varies with the pressure. Seventh one, name the force of attraction present in a physical adsorption. And the eighth one, chemical adsorption is an irreversible process. Give reason. So these are the 8 questions which are really important. Now let us start the today's class with Freundlich adsorption isotherm. The term isotherm stands for same temperature or constant temperature. Freundlich isotherm gives an empirical relation between the quantity of gas adsorbed by unit mass of solid adsorbent with the pressure at a particular temperature. It can be expressed by the equation x by m is equal to k into p raised to 1 by n, where n is greater than 1, where x stands for mass of the gas adsorbed, m is equal to mass of the adsorbent, p is pressure of the adsorbent, and k and n are empirical constant. In order to understand Freundlich adsorption isotherm, let us try to understand how the adsorption vary at a different temperature and a different pressure. In this graph, we are having along y-axis, let us assume adsorption. Along y-axis, we are having adsorption. And x-axis we are having pressure. So when the temperature is 195 Kelvin, as the pressure increases, the adsorption is also increases and reaches at a maximum point. So this much is the adsorption at 195 Kelvin temperature when the pressure is increased. But what happens when the temperature is still increases? So if we consider the temperature at a 244 Kelvin, So here also, as the pressure increases, the adsorption is also increases, but compared to the adsorption at 195 Kelvin, this adsorption is slightly decreases. So at a higher temperature, the adsorption is decreasing. When we increase the further temperature, that is at 273 Kelvin temperature, the adsorption is still decreases. So it indicates that when the temperature is low, the adsorption is maximum, and when the temperature is high, the adsorption is decreases. So as we increases the temperature, the adsorption is also increases. I hope you understood this. Only you have to remember that at a higher temperature the adsorption is low, at low temperature the adsorption is high. So this is how the adsorption vary with the temperature, and this point we have already discussed in the last class. Now let us see the Freundlich adsorption isotherm at a constant temperature and by varying the pressure. Here along x-axis we are having the pressure, and along y-axis we are having x by m. The x by m is nothing but the extent of adsorption. X by m is what? Extent of adsorption. Extent of adsorption means how much amount of gas is adsorbed on the solid adsorbent. So it is represented by x by m, where x is amount of the gas adsorbed, m is mass of the solid adsorbent. So together it is called as extent of adsorption. Okay, so we are having the extent of adsorption on a y-axis and pressure along x-axis. Initially when the pressure is increases, the extent of adsorption is also increasing. Look at the graph. So when the pressure is increases, the extent of adsorption is also increases, right? So we can say that x by m, that is extent of adsorption, is directly proportional to what? Pressure. Because as the pressure increases, the extent of adsorption it is also in what? Increases. So it indicates what? The extent of adsorption is directly proportional to pressure, right? When the further pressure is increases, the extent of adsorption reaches to its maximum point here. So here the adsorption, that is extent of adsorption, is a maximum. So at this point the pressure is called as a saturation pressure. The saturation pressure is nothing but what? The amount of the gas adsorbed is equal to the amount of the gas disadsorbed at a particular pressure, where the amount of gas adsorbed is equal to the amount of gas disadsorbed. इसका मतलब क्या है? जितने भी गैस मॉलिक्यूल एडजॉर्बेंट पे आ रहे हैं उतने ही गैस मॉलिक्यूल एडजॉर्बेंट से जा रहे हैं. So it becomes equilibrium state between the adsorbed molecule. Okay, so that pressure is called saturation pressure, where the saturation take place. It is nothing but what? The extent of adsorption becomes a constant even though pressure is increased, So when the pressure reaches to the saturation pressure, the extent of adsorption becomes high. After this point, the extent of adsorption becomes constant. It means what? As you increase the pressure beyond saturation pressure, it does not affect the extent of adsorption. extent of adsorption remains as it is. It means the pressure is independent on the extent of adsorption. So the extent of adsorption becomes constant when the pressure is beyond saturation pressure. It means that at a high pressure, so at high pressure the extent of adsorption, it is independent of pressure. इट इज़ इंडिपेंडेंट. जितना भी आप प्रेशर बढ़ाओ एक्सटेंट ऑफ एड्जॉर्प्शन क्या होगा, उतना ही रहेगा. सो एक्सटेंट ऑफ एड्जॉर्प्शन रिमेन्स कांस्टेंट एट हाई प्रेशर एंड देयरफॉर the extent of adsorption is constant and it is independent of pressure. So we can write down extent of adsorption, that is x by m, is directly proportional to the pressure raised to 0, where pressure becomes independent. So I am writing p raised to 0. So p raised to 0 is what, 1. So it is independent of a pressure. So x by m becomes constant here. So we have learned the two things from this. At a low pressure, यहाँ पे at a low pressure the extent of adsorption it is increases. At a high pressure यहाँ पे the extent of adsorption is almost parallel to the x-axis. It indicates the extent of adsorption is constant, it is independent of pressure. But what happens to the intermediate pressure? This portion is called intermediate portion. Okay, so I can write down at a low pressure extent of adsorption, that is x by m, is proportional to p raised to 1, because it is directly proportional to the pressure. As pressure increases, extent of adsorption it is also increases. At high temperature, x by m proportional to p raised to 0, proportional to p raised to 0. Remove the proportionality constant. We can have here at a low pressure x by m is equal to k into p raised to 1, and at high pressure x by m is equal to k into p raised to 0, because वो प्रेशर पे डिपेंड नहीं रहता हाई प्रेशर पे. Okay, so these are the two conclusion we will get. At a low pressure the extent of adsorption is directly proportional to the pressure, so we are having x by m is equal to k into p raised to power 1, and at high pressure we are having x by m is equal to k into p raised to 0. Okay, so what happens to the intermediate pressure, यहाँ पे क्या होता है? So we will get here, see, from initially when you increase the pressure the extent of adsorption is increases. At high pressure, so this portion at high pressure the extent of adsorption becomes constant, means it is independent of a pressure. So the pressure is lying between 1 to 0. The pressure is lying between 1 to 0. So therefore at an intermediate pressure we are having x by m is equal to k into p raised to 1 by n. So where n is an integer, so it may be 0 or it may be infinity. So at intermediate pressure we are having the extent of adsorption, that is x by m is equal to k into p raised to 1 by n. So this is a generalized form, you can say, from which we can get the extent of adsorption at a low pressure as well as at a high pressure by putting the value of n as a 0 and infinity. Are you getting? Okay. So here we are having the explanation for Freundlich adsorption equation. As we have discussed, at a low pressure the extent of adsorption is directly proportional to the pressure. Therefore we raise the power 1. X by m is directly proportional to the pressure, p raised to 1. Next, at high pressure the extent of adsorption is independent of pressure, raised to power 0. यहाँ पे हम raised to power 0 के. यहाँ पे raised to power 1. Therefore, at intermediate value of pressure, the adsorption is directly proportional to the pressure raised to power 1 by n. Here n is a variable whose value is greater than 1. Whose value is greater than 1. Therefore, we are having x by m k into p raised to x by m is equal to k into p raised to 1 by m. Using the constant proportionality k, also known as adsorption constant, we get the equation x by m is equal to k p raised to 1 by n. The above equation is called Freundlich adsorption equation. So this equation helps to calculate the extent of adsorption at a low pressure as well as the extent of adsorption at a high pressure. Okay, so here if you substitute the value of n as a 1, then we will get the extent of adsorption at a low pressure, and if you put the value of n as a infinity, then we will get the extent of adsorption at a high pressure. So by using this equation, we can find out the extent of adsorption at a low pressure as well as a high pressure. Are you getting? Okay, so this is a Freundlich adsorption isotherm which gives an empirical equation between the extent of adsorption and how it vary with the pressure. So this equation is really important. Okay, so now let's move towards the application of adsorption. So we are having tremendous application of adsorption in our day-to-day life. So let us study one by one. The first one, removal of coloring matter from a solution. So if the solution is colored, so we can remove that color impurity by using the charcoal, and that process is adsorption. So we can remove the coloring matter from the solution. Second one, it is used in a heterogeneous catalysis. So adsorption, it is used in a heterogeneous catalysis. The third one, in a separation of inert gases, adsorption helps. Fourth one, for production of high vacuum. Fifth one, silica and aluminum gels are used as adsorbents for controlling humidity. So this is also the process of adsorption. In order to control the humidity, there is a process of adsorption. And the sixth one, in a chromatographic analysis. So this chromatographic we have already learned in PUC first year. Okay, so in a chromatographic analysis, there is a process of adsorption. So these are the few applications which are important. Okay, so thank you.